Good morning, Regan. Right. Good morning again, everybody, and welcome to day 9 of the Matric 2023 cockroach session. And today we are focusing on one of generally sometimes confusing, challenging um, section, which is application of calculus. But if you get the hold of what you need to do, things will definitely be fine. You would enjoy it. All right. A lot of people are awake this morning as we join in the session. Welcome to Bang. Um, Others that are on YouTube live. Awesome. Guys, let's quickly get the ball rolling this morning. Okay, so we jump into application of calculus. And this morning, I quickly want to look at basic things before I move into question papers. What is it that I should know when the examiner refers to application? Now, when we talk about application, basically, we're referring to how to use calculus in daily lives. Now, the main thing here is to talk about maximum or minimum. Now, when we refer to this maximum or minimum, we're talking about stationary points, which we know on our cubic function, stationary point. And the most important thing to talk about is to say the first derivative. Don't let me restrict it to f of x. The first derivative be equal to 0. That's the main thing. So when I turn this into a cubic graph, this is what we are looking at. Maximum and this is going to be our maximum, and that is going to be our minimum. This is what we are basically saying. So mathematics is not just your solving for x or what, it is a live applicable subject. I'm going to run in through the different sections now. The first one is to talk about measurements. Please, the first one is to refer to what? Measurements. And when I refer to measurements, there are 2D measurements that you and I must know. 2D. What I mean by 2D, guys, you must know how to deal with a square, all right, or a rectangle. Please, there are some formulas that will not be given to us, all right, so we must know how to deal with it. Area here is simply length times breadth, all right. And when I have a circle, the area here is simply pi r square, where your radius is from the center. Please, these are basic things that you and I should know. We will then take this into the 3D dimension. For 3D, I'm going to look at just two things, and others, the examiner would supply you the formulas. But the basic ones, when it comes to shape, you will not be given. Oh, let me just add a triangle. All right, let me add a triangle to this. Okay, and the height must be perpendicular. Please take note. Area, therefore, is half base times height. No one is don't expect anybody to give you this particular 2D formulas. It's something that you should know. All right, Ramina Tabs, good morning. Good morning, everybody. Now, when it comes to the 3D, now you talk about things that have three dimensions, three sides. Okay, now we're talking about the length, the breadth, and the height. For example, if I look at this, this becomes Let me take this up a little bit. This becomes the height. This is the length. All right. Now, when you see things like this, guys, we will then be calculating two important things. For volume, there's a general formula for volume. It is the area of the base times the height. For example, if I look at this box, what do you notice? It is a rectangular base. Now, what is the area of a rectangle, the base? It's length times breadth. Now, multiplied by what? The height. And we are done there, guys. It's as simple as that. You don't need to cram it, just know your 2D. What about the total surface area? We're going to call it TSA after now. SA, total means all. So it is the sum of all areas or surfaces. The sum of areas of surfaces. Now, if I, please, guys, I'm going to teach you the generic one. You need to adapt it to the question. Okay. Now, if you look at this, it's a box that has 6 sides. Is that okay? So we're going to multiply the area of each side and, add it together. But the good thing here is if we start from the front and the back. So it is front and back, which are the same, plus top and bottom, which are the same, plus right and left side, which are also the same. So don't cram. If you look at the front, what do you see? This is the front, which has the same thing as the back. It's length times breadth. So it's 2HL. Why 2? It's the front and the back. 1 is just length times breadth, H times L. But because of the back as well, we do need. Now, the top, this is the top and the bottom. Oh, this is also going to be B, and this would be what? L. Top and bottom will be the same. Oh, so we can say 2 length times breadth plus right and left. This is the left side. Length times breadth. But right now is breadth times height multiplied by 2. And you are done, guys. Don't cram this thing, just walk around it. It's using your knowledge of the 2D and the 3D that you have. And you will just be okay. I see my circle here may just be too faint. Let's use faint. All right, there we go. Okay, guys, please. And the circumference of a circle is pi r or pi d. Let's take note of that as well. Pi d. Okay, and wherever you see a 90 degrees, just bring in your theorem of Pythagoras. Everywhere applicable. Okay, good morning to you, Deborah. Guys, understanding this just helps you. I'm quickly going to move, excuse me, to a cylinder. Now, what you should know about a cylinder is made of the top and the bottom circular part and the side. The side is actually a rectangle. So it is 2 circles plus a rectangle. Now, quickly, you will not be given this formula. Please take note. So let's go through it as fast as we can. Let's first find the volume. What did I say the volume of a 3D object is? Area of the base multiplied by the height. Now, but this base here is circular. Area of a circle, pi r squared multiplied by, and you are done by h. Guys, this is how we do it. That's the volume. Just know your 2Ds. Now, what about the total surface area? Now, the total surface area, please be careful with the question. I'm going to break this down into 3. Number 1, a fully closed cylinder. A fully closed, for example, like the one you have on the right hand side, it's fully closed. Like you have a can of Coke, it's fully closed. Okay, now what are we going to have? It has the top, it has the bottom, as the side. I quickly want to deal with the side for you. Now, the side, you can see here, it's a rectangle. So this is actually height. That's the height. What about this here? This part here actually comes from the edge here. That is the circumference of the side. That blue part there is the blue part. So this is 2 pi r. Oh, it means this is 2 r. Okay, that's the only thing that you need to understand. All right, so what if X Katleho? I'm getting there right now. All right, that's why I said I'll break this into 3 parts. Number one, a fully closed container. It has a top, it has a bottom, and the side. The SA would be, what is the top? It is circular, pi r squared. What is the bottom? Pi r squared. What is the side? Length times breadth, 2 pi rh. This can therefore be written as pi r squared. Please don't cram it, work it out. Are we okay? Now, let's check something. Number two, what if it is open at the top? So what area do we, what surfaces then do we have? We have the bottom and the side. An example, you have a glass cup. Of a glass cup. All right, a glass cup cannot be closed on both ends. It's closed at the bottom and open at the top. So it's going to be TSA. What is the bottom? Pi r squared. What is the side? 2 pi rh. That's it. 3. Open at both ends. Open at both ends. Example, you have a roll of toilet paper. You can imagine that, right? A roll of toilet paper, no top, no bottom. And imagine a straw. When you buy your cold drink, that straw has no top, has no bottom. It's a cylinder. So the only thing we have, the total surface area of the side, because it has no top. So what's your answer? 2 pi rh. Guys, that's how to work things out. The total surface area would be 2 pi rh. So there's no need to cram. Many of you are cramming, and that's why we find this a bit challenging. Okay, and the volume just remains the same. Whether it's top, bottom, opened, the volume remains the same, pi r squared h, because volume is inside what it contains. Okay, guys, we are done with that. We're going to apply this when we start looking at questions. Finally, let's look at this. You're seeing of a car there, so you should know I'm doing a bit of learners who are not doing physics. Please, important to you. Okay, guys, now we have 3 variables. The variables we have when it comes to motion. One is we have distance. Talk about distance, we are going to use S to represent distance. Okay, number 2, we'll have speed. And most here is the deal. Speed is over time. Aha. I'm going to tell you something now. Distance over time. Guys, immediately I see time as a denominator. Time as a denominator. known as rate. Time as a denominator is known as rate. And every time you see rate, rate means derive with respect to time. What do I mean? So speed is distance over time, all right? Which means speed is the derivative of distance with respect to time. Take note. It means I could then say my speed is ds dt. Take note of that. Once you see time as a denominator, we are now deriving with respect to time. Look at number 3. Same thing. Acceleration, which is velocity over time. What are we doing? We are now deriving, okay, velocity for now, because of us, those who are not doing science, velocity or speed over time. It means we are deriving speed with respect to time. All right, so we could use depends on the examiner, or we could write it as this: the derivative of v with respect as the derivative of s, because we know that's first derivative with respect to time. So please take note of these notations. We start from speed, that distance, which is s. When you derive that, you get speed or velocity. When you derive that again, you get acceleration, which therefore means acceleration, check now, is the second derivative. Showing you something just now. Acceleration is the second derivative of distance. Because if I then have the first derivative, would give me velocity. If I derive velocity again, I'll be having acceleration. So that's what you say. Acceleration is a second derivative. That is actually the point of inflection. Yeah, that's the point of maximum speed. So the question is, when do I derive? When do I derive? When do I derive? Okay, we're going to see questions now, and we'll be looking for certain words. Right? Those words would tell us when to derive. When do we derive? Number 1, when the examiner tells you maximum. Number 3, when the examiner tells you the rate. All of these means derive. All of these means. Now, number 4, when the examiner says derivative, this 3 is only a first what? Derivative. Okay, and we derive again. When I talk about rate, we're talking about when a variable changes. Variable changes, whether it is increasing, right? Increasing or decreasing respect to time. Example, if I say the velocity, the speed or the distance is increasing with time, increasing or decreasing with time, I'm saying are the things you should be looking for. Definitely, you know that our first derivative That's your key there, because we're talking about turning point and stationary point. All right, let's quickly apply all of this knowledge to some questions that we would be able to cover in the short time remaining. Look at this one. Please take your time to read. After traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close a tap in his garden. He then turns around immediately, now check, and returns. Read, underline. All right, it turns around immediately and return. There's a big meaning here when we use the word return. So don't read oblivious of the things that are going on in the question. Don't be absent-minded. Every word matters. He returns home to close the tap. What does that mean? Guys, it simply means this guy has covered, we don't know where we're going yet, but he has covered a distance of 40 kilometers. After traveling a distance of 20, he remembers, then he returns. So it's 20 forward. I hope that makes sense. 20 forward and 20 backwards. The cost of the water at the rate the water is flowing is 1 rand 60 per hour. Now somebody is saying, how are we going to transfer water now to the distance? Okay, wait. The cost of petrol, oh God, is this rand per kilometer, where X is the average speed. Do you see that? Now we're talking about the things we spoke about. Average speed, which is what? Speed. They said kilometer over hour, and that is distance over time. That's a derivative there. Calculate the average speed at which the person must travel to keep his costs as low. What does the word low mean? Minimum. Okay. Keep his average, please listen, you need to read. To keep his average cost, which means cost must be minimum. It means whatever we do, guys, we need to derive the cost. Now, what is the total cost this guy is going to be incurring? Let's see. It is the cost of traveling, which is the cost of petrol, okay, plus the cost of water running. Oh God. So interpretation, cost of water. But do you notice that they gave us 1 rand 60 per hour? The question is, for how many hours has this water been running? This is what we are going to now walk through together. So let's break it down, guys. The cost of petrol. I'm going to go to a fresh page so that we can work together. But this is a mind map for me to see what to do. Now, let's walk through together. Let's look at petrol. I'll be going forth and back. All right. Cost of petrol. What do we know? The cost of petrol. We're given something. What's the rate? 1,2 plus X over 4,000 per kilometer. All right. So the cost is 1,2 plus X over 4,000 rand, okay, per kilometer. Per kilometer means for every kilometer. The question is, how many kilometers did this guy travel? All right. How many kilometers did this guy travel? Remember, he traveled 20. Okay. Let's go back to the question. After traveling a distance of 20 kilometers from home. So he already traveled 20 there. Okay. Then what happens? A person remembers that he did not close the tap in the garden. It decides to turn around immediately and return home. Okay. So what do you think? The distance traveled, therefore, is 40. But he is paying 1,2 plus X over 4,000 rand for every kilometer. I hope that makes sense. All right. So the total for The total cost will therefore be 1, comma 2 plus x over 4,000 multiplied by what? I hope that makes sense. Okay, let's see something. For the what? Let's see for water. We are given the cost of water at 1 rand 60 per hour. All right, 1 rand 60 per hour. Let's water. 1 rand 60 per hour. The question is, how many hours has this guy traveled? How many hours has this guy traveled? We don't know. But we know that speed is equal to time. If we cross multiply, speed times time equals to distance. Now, we are looking for time, remember? Or let's do this. We don't know the time, but do we know the speed? We are told average speed is x. Sweet. X, know the distance? 40. Over what? Time. X equals to 40. What is x? We're looking for time, right, brother? Time is better. Time, therefore, is 40 over x. Okay, so guys, we know the time as 40 over x. It means the cost of water, because it is 1 rand 60 per hour. How many hours has this guy used? 40 over x. So we have 1 rand 60 times 40 over x. Or we can quickly get a calculator to simplify all that we need to simplify. So let's see the total cost here. 1,4 times 40, that would be 8, okay? Let's get a calculator. That should be 4,8 there. 1,2 times 40 would be 8. Yeah, 1,2 times 40, 48. But remember, 40 over 4,000. So what are we going to have? We have 48 plus x over. If you say 4 divided by 4,000, all right, that 0 there cancels 0. We have 100. I hope we are making sense together there. What about the cost of water? Calculator quickly. What do we have? 1,6. Oh. Our total cost, therefore, will be the cost of the petrol that he incurred. Total cost, we're going to say 8 plus x over 100, which is that of the petrol. Is that okay? Plus 64 x. I hope that makes sense. This is our total cost. This is our total cost. Let's put this in terms of x. Our total cost in terms of x. That is, I hope, guys, it makes sense. But that's not what we are interested in. We want to make the cost minimum. How do we make this cost to the minimum? Minimum cost, we're saying C prime of x must be equal to 0. So we need to derive. Okay, let's get back to our laws of derivative. Get back to our laws. This is still cost in terms of x. 48 plus x over 100 plus what? 64, x to the power of -1. We cannot derive, right? We cannot derive with x as a denominator. Okay, so now what is the first derivative going to be? 48 would be 0 because it's a constant. X to the power 1, if you remember that. So that gives us, we bring the 1 down, 1 over 100, because we subtract 1 from that exponent and it's gone. Now, minus, this is -1 on top there. When it comes down, it becomes -1. 64 x to the power of -2. Oh, that's what we have. Now, let's do the simple maths now. All of this must then be equal to what? Or we can just return this back. Now, let's solve. If I bring the 64 over, what would I have? 64 over x squared equals to 1 over 100. Can we cross multiply? X squared will be equal to 6400. That makes sense. Now, what's the square root of that? That would be square root of 64 is 8 and 0. Oh, beautiful. So the guy should be traveling at 80 kilometers per hour. We are done there, guys. It begins with you understanding the question. Many of us just rush. Take your time. It's up. That's guys, that's why we call it application. It's life applicable. So please, you take your time, you read the question, the total cost. We could have also calculated the cost of one journey. All right. So instead of using 40, I could have used 20. Is that okay? I could have used 20 throughout. I'll still get the same. Try that using 20 because we're saying since the speed is average, the time it takes the guy to go would be the same time. I've used 20 kilometers, we will still get the same answer. Let's try another question quickly. Also cost, but this has to do with the shape. A closed rectangular box has to be constructed as follows. Dimensions: length L, width W, and height H. The length of the base has to be 3 times. Look, they didn't give you this. Why don't we just have a small diagram just to guide us? Let's just create something quick else. You know how we used to draw that when we're all in primary. Hey, let's just, that's it there. Now, the length of the base has to be 3 times the width. Okay, length here has to be 3 times the width. And the volume has to be 5 meter cube. Please take note. Remember what box? It's a rectangular. They won't give you the formulas. The material for the top and the bottom parts cost 15 rand per square meter, and the material for the side costs 6 rand per square meter. Show that the cost to construct calculated as given as that. Get that formula, guys. Definitely need to get that right. All right, let's see. Check. The formula has W and H on something. Let's walk around material for the top and bottom, okay? Up plus bottom. The examiner says per square meter, which is area. That's telling you we need to find area of the top and area of the bottom are actually the same. All right. So what's the area? It's a rectangular. It's length times breadth. Okay. So area of top plus bottom. The area of the top and bottom, it's 2 multiplied by, I hope you see where the 2, W times W, and that will give us 6 W. That makes sense. It's 3W squared at the bottom, 3W squared at the top to give us what? 6W squared. That's just the area. Now, what is the cost of the top and the bottom? The material for the top and per square meter. Okay, awesome. Our cost will be 6W squared times 15, and that will give you 90W squared rands. Okay. Let's remove the R so it doesn't confuse us. All right, that is my top and the bottom. Beautiful. Let's go to the sides. Let's check something on the sides. The sides. All right, there are four sides. So when I say side, I'm going to say the left and the right plus the front and the back. So the area would be, if you look at the left, you would see that it is HW. Do you see that there? But there are two of them. So what are we going to have? 2HW plus front and back. Where's my highlighter? That's the front. H, let me use a green one. And L. You see, that's the front there. Rectangle. What are we going to have? H multiplied by 3W. But again, there are two of them. H multiplied by what? 3W. Okay, let's put an by this. What do we have? 6HW. And that will give us 8HW. What is the cost of the sides? It costs 6 rand. 6 rand per meter. Okay, so it's 6, 8HW. That will give us what? 48HW. So what is the total cost therefore? Is the cost of the sides and the top and bottom 90W squared. Sides 48HW or WH. That's what the examiner wants. Check. We are done. Done with our 4 marks. Guys, it's about knowing your 2D and your 3D formulas. Determine the width of the box such that the cost to build this box, again, what are we looking for? We are looking for the width, but the cost must be a minimum. Right. Quickly, guys, before you derive, look, we have the formula for the cost, but there are 2 variables on the cost. Don't derive with 2 variables. Please take note. I'm going to write that small note for you. Don't derive with 2 variables. Check the formula first. Don't derive with 2 variables. Let me take that out. We got our cost, check, we got the cost as 90W squared plus 48. They said determine the width. Okay, so we're looking for W. But if you check with W there's H. Get rid of the H and only have W. Somebody's not saying, but how do we get rid of the H? Let's go back to the question. The volume has to be 5 meter cube. Oh, what is the volume? Area of the base. Remember, we said area of base times height. So my volume is 5. What is the base? Length times width, yes, which is what? 3W squared multiplied by the height. What is the height? Because we have to get rid of that height in terms of W. So it's going to be what? 5 over 3W squared. That's the first thing I'm doing. So therefore, the cost can be written as 90W squared plus 48W. Instead of writing H, I now have a solution for H. I want my answer to be in terms of W, since I'm looking for W. We can simplify. The cost, therefore, will be 90W squared. 48 there, that is 0.4. Okay, oh, but divided by 3, which is 80. Okay, that is 80 over. Now, this W would take out 1 W there. Check. 80 over W. 80 over W. Please use a calculator in an exam. Don't try to do what I'm doing. It's 8 times 5, all right, divided by 3. Okay, now this is the cost in terms of the width. I should actually put that there. This is the cost in terms of the width because we want the width. Now, since we want it to be minimum, a minimum cost means that our first derivative of the cost with respect to W should be equal to 0. Then we derive quickly, everybody. Remember, don't keep W as a denominator. I'm not deriving yet, okay, which is 80 W to the power of -1. Now let's derive with respect. What are we going to have? 2 times 90 would give us 180 W. We subtract 1 minus 80, all right, W to the power -2. Now that must be equal to, let me take that to a fresh page. That must be equal to 0 so that we have space. 180 W, all right. These questions are not as difficult as people really say that are. It's just a matter of being careful and doing it well. What do we have? 180 W minus 80 W squared. We have 180 minus 2. Minus 2. This would give us 80 over W squared. Okay, there's a W here, right? And that is equal to 0. Now, how do you solve this, my dear learners? I would say get rid of the denominator, or if you like, you can cross multiply. Okay, let's do your cross multiplication. A lot of you like that. 80 over W squared equals to 180 W. I brought that over to the other side, right? And if I cross multiply, what would we get? 80 equals to 100. And from here, I'm sure you know what to do. We can therefore say W cubed will be what? 80 over 180. And you know that the rest is now history. For the cube root, right? 80 over 180. Let's just grab a calculator quickly. All right. Over 180. And what's our answer? 0,763. But we always write in two decimal places. 6 meters. Done, guys. That's how we work things out. I hope it makes sense. I think we have time for one more. This one, someone sent me a question, so I'm just going that request. But I hope it's making sense, guys. All right. A piece of wire, 6 meters. Guys, please read. I know we are lazy to read at Mets learners, only want to calculate. Please read. It's a plea. A piece of wire, which is 6 meters. Look, don't make assumptions. 2 pieces doesn't mean half. Somebody's already saying 3, 3. No, it's 1, 5. It could be 2, 4. Okay. 1 piece is X meters long. Let me move this to the. One piece, all right? 1 piece is X meters long. Okay. If 1 piece is X meters long, the other one is going to be 6 minus X. That is 1, and that is 2. 1 piece out of the 6 is X. It means the other piece will be 6 minus X. 1 piece X meters long is bent to form a square ABCD. What do you know? It has 4 sides that are equal. Oh, the total is X of that piece. What will be the measurement of one of the side of the square? All right, because it has 4 sides that are equal. It's 4 X over 4 and X over 4. Makes sense? So we take one piece and divide it into 4. The other piece, oh, what is the other piece? 6 minus x. Now bent into a U shape so that it forms a rectangle. Please take note. Oh, so they joined it together. When placed next to the square as shown in the diagram below. Let's deal with the dimensions here. Now, because this is a rectangle, EF will also be x over 4. Right. The question is, what is BE and C? Let me quickly get to a fresh, this is algebra, guys. This is back to question 1. All right. BC, EF, and CF. Please take note of this. Take note of the letters I mentioned. We are looking at, we're going to look at the U-shaped now. Okay. We are looking at the U-shaped. Let me use a white to quickly draw that U-shape. Let's get the labels. B, E, F, C. All right. B, F plus EF is equal to 6 minus X. You remember the 6 minus X, right? Lovely. But we know EF as X over 4. We need to get all the dimensions before we can even start working, guys. We must know all our dimensions. Okay to say these two are equal because they are opposite. Therefore, can we say 2? Okay, let's see. 2 minus X over 4. Guys, try to simplify this. 2, I can write this as 6 minus X minus 1 over 4X. All right, this can be simplified. These are like terms with the x's. Minus 1 and minus 1 over 4 would act x. This is 2. But now, what is BE? Because we need all the dimensions to be able to walk through this. Struggle with this, okay? Or you can say multiply both sides by half. That would actually be a lot easier. 1 over 2 minus 5 over 4. Divide both sides by 2. Okay, Tiamo. Right? Tiamo says how I should explain x over 4. Okay, I'll go back there now. Let me go back there quickly. Tiamo, it's a square. What do we know about a square? A square has 4 sides, and all the 4 sides are equal. Is that okay? So, side 1, side 2, side 3, and they are all equal. Let's call it L, 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 L. Since they are equal, it means 4L, and the total, the perimeter, is X. So what is L? X over 4. And this is now a rectangle. Opposite sides are equal. X over 4, X over 4. Hence, let me know if you get that, Tiamo, as I need to run through quickly. All right, guys, I said we divide both sides by 2, which is same thing as multiplying by half. If I lost you there, let me find you. Minus 5 over 4x. Right, everything divided by 2. And 7 or grade 8, and not grade 8 basically. And this is why we need to learn to use without calculators. Division times, and we reciprocate. So what minus 5 over 8x. Oh, sweet. We now have BE. Now, let's quickly check. Find, it says, oh, I forgot to actually read because I was excited. Okay. All right, you got it, Tiamo. Awesome. Now, the question says, calculate the value of x for which, listen, read, the sum of what? Of the areas. Oh, so it is the area of the square plus the area of the rectangle. All right, enclosed by the wire will be a maximum. We want which one should be a maximum? Area, but it's sum of the areas. Oh, so it is area of ABCD plus area of BCFC. That's why we need all the measurements of the side. Now go calculate. So total area of ABCD plus the area of BEFC, and that's rectangle. But this one as well is just length times breadth. X over 4, area of a square, guys, length times breadth, squared, plus area of a rectangle. Now it is BE multiplied that. Do we know BE? 3 minus 5 over 8 x multiplied by the side, x over 4. Please, I hope that makes sense. A rectangle and a square have the same principle of area. That's why I have, let me write this out, okay, as x over 4. So our area is in terms of x, right? Remember, area, both of them, we are dealing with length. Matter of simplification, my dear learners. Right? What do we have? X squared over 60 plus we FOIL, or we expand rather, we use that to multiply. What is 3x? This is 3 over 1, guys. So it's 3x over 4. I hope that makes sense. All right, minus 5 on top there, but it is x squared over 32. Take your time when it comes to algebra, multiply carefully, use a calculator when necessary. All right, guys, this is what we have. Doesn't really look nice in presentation. There are like terms. Okay, and my like terms both have x squared. So can I bring them together? X squared over 16 minus 5x squared over 32. They are not deriving yet until the 5. Let's check now. Let's get a calculator. 1 over 16 on x squared minus 5 over 32. Oh, we could actually do this without a calculator. All right, that is minus 3 over 30. Minus 3 over 30 x squared plus 3x over 4. This area. But the examiner, sum of area, sorry. But the examiner says we want what? Is it a maximum? Let's check. Maximum. The sum of the areas must be maximum. So that is what we are going to now derive. Sum of the areas must be. What would the derivative be? The derivative would be equal to. Okay, so let's quickly out. Beautiful. Once you do this, this one is actually grade 11 applicable. All right, a grade 11 applicable question. So let's derive a that you are able to see. Just if you are going to find maths difficult. You start losing steps. Subtract 1 from there, 2 minus 1. I'm deriving plus 3 over 4. Right? 3 over 16 plus 3 over 4. And this is how we solve it. We're looking for x. What is comfortable for everyone? Are done. Guys, please enjoy this. Enjoy it. Always go back to the question to confirm. We are calculating x. Is that okay? They ask you to calculate the maximum area. Then you throw the x back into, please, always value of x. I only have 2 minutes left. I really wish. Let's try this one quickly. The above shows the design of a theater stage, which is in the shape of a semi R, and a rectangle has a. The perimeter of the stage. As when we talk about the perimeter, let me quickly add it to that page, and you can also go back and circle and the perimeter. Good, good, good. This note is good. Check my other videos and other questions I have done, and you'll be able to walk through. Expression for B in terms. Okay, let's see. And it's 2 marks. B in terms of R. Oh, so the total perimeter is the distance. R, I'm going clockwise. We come back to B, and then we come R, we come back to B, and then we go back there. Makes sense. All right. But we have a value for the perimeter. It is plus B is 2B, R plus pi R. What are we looking for? Object. What do we have? 60 R minus R equals to 2B. Can we divide everything by 2? R divided by 2 will give us R, right? Minus pi R. That is our B. That is our B. Let's finish up quickly. Find the value of R for which, check again, for which the area of the stage. Guys, want to read carefully the area of the stage. It is the area of the rectangle plus area of half the circle. Okay, let me. I started this question, so we need to finish, guys. I want us to make reference quickly. Okay. Area. So the area, we want the area. Area will be of rectangle plus area of semicircle. Let us pi r squared over 2. Because length again, it is b plus pi r. Guys, the examiner says find the value of r. So we need to get rid of b. What is b? 30 minus r. 30 minus r minus pi r pi r squared over 2. Multiply in 30 times 2. What do we have here? The 2 can divide plus pi r squared r is 60, so that we have but we can leave it like that to make it simple, and we need to derive. Okay, let's leave it like that. A prime of r must be equal. 1 times 60 would give us 60 minus 4r. Now, what about this ones, guys? What about this ones? How do we derive? Remember, we are deriving with respect to deriving. I think I'll prefer us to don't get rid of that 2 now. We are not a in terms of r. Some of you are going to say, okay, excuse me. Now, but let's check something. Let's check something. I want to see a way of cos pi over half of that minus 1 plus 1 over 2. So it's half. Finally, I'm taking extra time. Let's then derive. Can I derive on a fresh page so that we end this session now? All right, let's derive quickly. Get rid here. So what do we have? Okay, the area, can we simplify? So this must be equal, but 0. So Add both sides, or you want to multiply first? Right. We now have r multiplied by 2 would give us 4r. R multiplied by pi over 2. The 2 would be that. Now, what is common? Can we then find r? R is your calculator can handle that. And okay, guys, I am done. I know it was a lot of math. I was just trying to make sure that we find it simplified. Please go through the steps, check. I hope walking through. And that, guys, it has helped you. Unfortunately, I cannot go further than that. That is how to deal with all your answers, my dear learners. Have a lovely, lovely day. You can try it, guys, but see, lovely, lovely day. As we'll be doing analytical geometry. Don't forget to share, send likes to everyone, and please leave. Lucky would get to pick your question. Hi, everybody. Crazy Physics signing out. We love you.